Good afternoon, everyone. Thank you for joining us for this session of what's next and what's new in Azure infrastructure. With me today is Aung from Azure Storage and Narayan from Azure Networking. They both manage PM organizations for networking and storage. And I'm Igal from Azure Compute, managing the Azure Compute product organization. Again, thank you so much for coming, and let's get going with the content. So in this session, we are going to talk about three big things. First of all, we are going to talk about simplifying the experience for becoming secure and resilient just from the get-go with applications built on Azure infrastructure. We are going to discuss our new focus on workloads, making sure that we optimize our infrastructure for the workloads running on it. And we are going to discuss which workloads and how exactly are we optimizing. And last but not least, how can we simplify the management of the infrastructure with Azure Copilot? We are going to discuss, even though we won't have too much time, but we are going to discuss how to make it simple to manage this whole complex, which is just getting more and more complicated. How to make it simple. So let's get going. Your IT estate today is expanding. It's expanding faster and faster, faster than ever. Cloud infrastructure is becoming more complicated. And in order to manage it effectively, we are thinking about three types of workloads that we want to support, that we want to focus on. First one is business critical. Those are workloads like ERP from SAP, payment workloads, things like that. Those need to run continuously, never stop, always available. Many of you are familiar with those workloads. This is kind of a foundation in many cases of our business. Cloud native, those are new air workloads born in the cloud. They need immediate elasticity. They need scalability. Overall, we need to enable the developers to develop, to ship more and more workloads that will support our business. Last but not least, AI native workloads. Those are agentic workloads. Those are inference workloads. Those are required in order to transform our data, our insights into decisions, into activities, into actions. And those are new and upcoming. With our advanced Kubernetes solutions, with our new Cobalt 100 support, Cobalt 100 processors, we are enabling all those workloads, and we'll continue doing so. So let me start by sharing first what are we doing in terms of resiliency by default. In fact, when we are thinking about resiliency, there is a resilient foundation. An important part, this is where we need to make sure that Azure itself is resilient and never fails under any condition. Then there is a question of a customer application. We need to make sure that our customer's application always run. In order to do that, we expose certain features, resiliency features, that could be consumed by an application. And when we are talking about resiliency, we are talking about the entire cycle. We are starting from making our infrastructure resilient, but we are ensuring that our customer applications are built from the get-go in a resilient way. We have a set of new announcements, and there are specific sessions to discuss it, but a set of new announcements about the products that are working together now, either through Portal or through Copilot experiences, that will help you to grow your application and make it more resilient. From the point of time when you define the resiliency goals for your application, you are able to get recommendations how to achieve those goals specifically for your application. And you are able to perform drills, assess whether impairments that would trigger resiliency are actually working for your application, whether your application can recover from those failures. There is a set of networking features, and we're actually announcing preview for Zone Resilient NAT Gateway and for ExpressRoute, which is now supporting max resiliency at zone, metro at site as a GA. We're announcing those network capabilities to support resiliency at the application level, the best possible resiliency at the application level, at the network level. And last but not least, we are still focused on the BCDR capabilities that we had for a long time. We are enhancing them, we are modernizing them, including Azure Backup, I am going to talk, though, about some new innovation on Azure disks. But we continue supporting the resiliency in every level of the platform. And again, we are thinking about how to simplify the adoption, how to make it easy to use it. Azure Disks Instant Access Snapshot, which is entering public preview, is a new functionality that allows us to quickly recover from Snapshot. This is much faster, this is much more effective, and it allows us to eliminate delays caused by the traditional copy processes. When we are thinking about scenarios like rolling back after the update, or even creating a snapshot for your AI agent, for your test application, this becomes instantly useful. From the security perspective, it goes hand in hand with resiliency. We want to make sure that our platform is secure from the get-go. So what are we doing? We are reducing the attack surface with hardware-rooted trust and verified boot chains. We are preventing credential theft with VM disk and key protection, plus just-in-time access. We are maintaining resiliency with automated patching, baseline hardening, and AKS security controls. Last but not least, we are protecting AI-driven workloads. We are protecting AI agents by enforcing isolation and eliminating embedded secrets in the applications, in the agents. There are a few features that I wanted to highlight out of the larger list, and there's a long list of what we're announcing or where we are adding new functionality, but just a few to highlight. Azure Confidential Compute allows you to run trusted enclaves, secure enclaves. We are offering confidential clean rooms that are accessible from the entire infrastructure, and those confidential clean rooms can allow two parties without trusting each other share the data and create and implement computation based on that shared data, which might not necessarily owned by one or the other party or entirely owned. So kind of coming together and implement the solution. We are continuing our investments in making Azure hosts, Azure physical machines, more secure by implementing Azure Boost. Who knows what Azure Boost is? Some. So Azure Boost is an accelerator board that allows us to offload some of the computation, some of the network connectivity, some of the storage connectivity, and some of the assistance to the host management into a separate offload card, hardware card. And it allows us to further implement secure machines, secure environment by isolating the management environment from the customer computational environments. So let me get going, and let's talk a bit about the business critical aspect, business critical application aspects. So as I said, those are systems like SAP, Oracle apps, core banking systems, and more. And those applications, what's common between them is they require high availability, they require security, they have strict compliance and performance requirements. So the experience is pretty polished, pretty perfect. Those applications are required to meet very specific SLAs. I'll just give one example. Nestle was working with us to transition 2,000 terabytes of their SAP environment, which is more than 10,000 servers, 6 data centers, and as they transitioned into Microsoft infrastructure, they said that first of all, they're happy, but more importantly, they said that their reliability increased, their downtime decreased, and overall the application serves their needs better. So what are we announcing today? This is why you came here, for the announcements, right? So what are we announcing today? There is a new Azure Boost, I'll talk about in a moment, acceleration. We are putting hardware acceleration, our third generation of hardware acceleration into our servers. We are announcing 5th generation AMD EPYC Turin VMs. We are announcing latest Intel Xeon VMs based on Granite Rapids. We are announcing new network optimized and storage optimized SKUs. Those are virtual machines that allow better networking bandwidth, better storage bandwidth. We are announcing the latest confidential VMs with 5th generation Intel Xeon processors and Intel Secure enclaves. There are networking innovations, and there is a few announcements on storage performance. I just want to highlight one thing. We are announcing a few new L series sizes, those are storage sizes, and this is just partial announcement list. There's going to be many more coming just within next year, but that's one another thing to keep in mind. We continue innovating on that side as well. So for network optimized VMs, those are new VM series, and they are mostly optimized on creating much more bandwidth per virtual machine. I have the numbers here on the slide, but the idea is that those virtual machines are becoming faster and faster, and even virtual appliance providers are now feeling comfortable using those machines at scale. So we are looking into scenarios where network bandwidth is the focus of the virtual machine. So this is Azure Boost. That's how it looks like. In the center of it, there is a device, our own hardware device that we are using, a programmable hardware device that we are using to implement the hardware offload, create much faster networking, storage access, isolate the hardware, isolate the host, the physical host machine from our code, from our management code, so it provides better security. Better maintenance. We are shortening our maintenance time, improving our maintenance impact by implementing this hardware offload. And this is, as I said, it's a short version. Let me just explain how it works. I saw that not many hands were up. So in the traditional machine, you have a hypervisor, and you have a customer workloads, virtual machines or containers. And there is a hardware layer. In the new environments that we created, VMs and containers are running on the physical server, on the physical host. But there is some kind of translation layer, I/O acceleration layer, that is now using the hardware accelerator in order to provide much faster access to network, storage, and implement some of the management agents on the machine. So what this means is that the execution environments for the virtual machines and containers is much more predictable. And this also means that security and maintenance are better addressed. So let's talk about numbers. This is where I'm extremely proud. We are offering 20 gigabyte per second storage access with 1 million of IOPS, Azure Disk IOPS, in our latest Azure Boost. This is, those are industry-leading numbers. We are offering 36 gigabyte per second local SSD access with 6.6 million IOPS. This is not industry-leading numbers. Those are way ahead of the industry numbers. And we are super proud that we were able to bring this innovation with Azure Boost. And this is the innovations that we are happy to put in the hands of our customers, get better cost performance for virtual machines running on Azure. We are, since when was it? In April, we increased by a factor of 2 our speed, our connectivity speed. Like, we are innovating multiple times a year. That's how fast it runs here in AI age. We are offering 400 gig per second connectivity and 400K connections per second, and a bunch of other stuff. I won't go over every item. I just want to say that we are extremely proud of the advancements we are making, and we are continuing to push the industry envelope, not Azure envelope, the industry envelope. Another industry first thing is Azure Boost Confidential Device, as we like to call it internally, ABCD. It's a nice name, somehow. So ABCD allows us to implement confidential computing together with accelerator. So our accelerator doesn't become a hole in our security implementation, but becomes an extension for our confidential environments. So I want to announce one more thing. We are continuing pushing our business critical applications demand with single-digit millisecond latency and high IOPS. We are focusing on handling large transaction volumes, and backend storage is becoming essential. So our goal here is to create the best-in-class business continuity, top performance. The numbers are here. This is with previous Boost generations. Also, we are pushing the envelope higher. This is just the previous generation. We are it's coming so quickly that we are not even updating the slides as fast as the performance grows. And of course, greater cost. As we are able to fine-tune the definition of the ultra disk, we are able to save 20 to 50% on implementation, depending on your environment. But the idea is give you control so you can have better cost performance for the environment. And let me show you a video. Yeah. Describing what we are up to.
Here we have an 𝗦𝗽𝗻𝗀𝗃𝗃𝗃 v3 VM, capable of delivering 650,000 IOPS, ideal for Tier 1 databases like SAP, or critical healthcare systems, such as patient record databases. This VM represents a production database environment with 12 Ultra disks attached to it to store the database files. We also have another VM called 𝗦𝗽𝗻𝗀𝗃𝗃𝗃. It acts as a secondary environment where we'll restore data from production snapshots, simulating a backup and restore scenario if the primary system fails. As you can see, this VM currently has no disks attached. Next, we will seed this VM using snapshots from the production environment. Here's the list of snapshots from the production VM. Note the access date is set to Instant Access. We released the public preview of Instant Access snapshots for UltraDisk and Premium SSD v2, which you can enable during the standard snapshot creation process. In the background, I started a script to create disks from these Instant Access snapshots. As we switch back to 𝗦𝗽𝗻𝗀𝗃𝗃𝗃, you can see the disks have been created from the snapshots. We've now kicked off an EMR database I/O simulator to replicate a heavy production workload with continuous read and write operations. As you look at I/O stat, notice the near millisecond response times and approximately 500,000 IOPS across all disks, even while they're still rehydrating from the snapshots. This showcases Azure's ability to deliver consistent, high-performance disk storage during the intensive data recovery. For enterprises running mission-critical applications, this means rapid recovery from failures with virtually no performance impact.
Okay, I'll skip it given the time, and let me reintroduce Narayan. Narayan, to you.
Thank you. Everyone, hope you're having a great conference so far and a lot more to go. I'm going to talk about cloud-native applications, right? Cloud-native has fundamentally changed the way applications today are built, deployed, and managed, right? And as most of you know, cloud-native applications are microservices loosely connected. They're not like the monolithic ones that we are used to. They are built to take advantage of the cloud, right? Cloud-native. And they rely on infrastructure being available as a programmatic goal state, or infrastructure as code. They're very dynamic. They go up and down. So the ability to scale in and scale out is super important. So from our experience running cloud-native applications, the key things that we observe as demands that we should meet, number one is elasticity, right? So the cloud-native applications thrive on the ability to scale in and scale out as needed. They're usually short-lived. So the control plane needs to be responsive to ensure that the pods can come up and go down fast. And they want to focus on their application logic and leave the resiliency and infrastructure portions to the underlying platform. So they are cloud neutral as well. So it is our duty in Azure to earn our rights to kind of keep these cloud-native applications running in Azure, for which we really have to have secure networking. We need to have proper isolation. We need to have proper resiliency controls, like zone-based resiliency, regional failovers. And all of it has to be delivered in a cost-optimized way, because they thrive on being effective in cost. That's why they come to the cloud. So these are the key demands. I'm going to walk you through some of the work that we've been doing to address some of these demands of cloud-native applications, and also talk about some recent announcements that we are going to be making. So number one, let's talk about the control plane. The control plane in Azure, as all of you know, is API-driven. It's ARM-based. You can create VMs, and you can delete VMs. But for a cloud-native applications, a lot more goes in behind creating of a VM or a VM scale set. The storage then needs to be set up. The networking needs to be ready. And deletes are as important as creates. Because like I said, these are very short-lived workloads. So you need to recoup your resources by deleting them. So delete needs to be super fast as create. And so we have really been working on improving the performance of our control plane. Recently in compute, we are able to deploy 5,000 VMs in a single call. And all of the networking that is needed for that is set up by the time the VM call returns, right? So just in networking, we have made the creates and deletes almost like 5x improvement over the last year or so. And we also have soft deletes feature right now, which enables you to quickly recover if there's an accidental deletes. And networking as well, by shared VNet architectures and NIC injection has provided the performance needed for cloud-native applications to be dynamic. Talking about control plane, we know most of the cloud-native applications are run using AKS, right? So today we are announcing managed system node pools in AKS Automatic. So AKS Automatic is not new. It's been there for a year, where we take control of managing the AKS infrastructure, where the users focus on the business logic of the pods. Now, system node pools are an important construct because they run critical services like core DNS and metric data servers. And these needs to be run in a separated, isolated pool. And typically, we allow customers, or we let or expect customers to run them in a separate pool, take care of the right VM SKUs to pick for that, make sure that they're proper resilient throughout. But we don't want customers to have that burden. So we are announcing that can be fully automated as part of AKS Automatic. So we will be running customers' system node pools in a separate pool. We will choose the right VM SKUs for it. We'll make sure they are deployed across zones. We'll make sure they are patched. We'll make sure they are running always. They're always available. Because if these core services are not available, the pod applications wouldn't work well. So that's one less thing to worry about. If customers are doing AKS Automatic from today onwards in public preview, they can also delegate the management of system node pools to Azure. Now, if you know which SKU to use, a good one to use would be the Cobalt 100 VMs, right? This is Microsoft first-party silicon, by far provides the best performance compared to its competition. When we run this, for web applications, we see up to 1.4x, improvement in both general-purpose compute and memory-optimized VMs. Many of our internal customers, as well as external customers, depend on Azure Cobalt 100 VMs. So what are we doing with it? We are making sure it's available in more regions, as many as 50% of all Azure regions. And we continue to make sure that they're resilient and available to everyone. Now, what's exciting here? You probably, whoever went to the keynote today morning, already know about this. But now we're also announcing Azure Cobalt 200, right? This will be the most, the best performing VM in cloud. And this will provide even 50% higher performance on top of Cobalt 100. We've been running so many benchmark tests to help with the design of Azure Cobalt 200 that we tested with AKS, tested with the cloud-native applications, and we've determined that this will be the best suited VM SKU type for that. And we also will be providing all the innovations like Azure Boost, Azure HSM inbuilt with it. So, and many of our customers, are going to be using Azure Cobalt 200, those who already use Azure Cobalt 100. So let's hear from one of our customers, David Myers from Databricks, on their use of Azure Cobalt 100.
Hello, everyone. Thank you so much for allowing me to speak to you for a few minutes. I want to share our journey, Databricks' journey with Microsoft Azure, and how the partnership has really shaped the innovation. So we got started, back in 2017, 2018 with Azure, but since 2013, we've been trying to unify data and AI at scale, expand access to data to all people in an org and access to AI to all people in an org. And of course, initially it was more boring AI, classic ML, math, and now it's included the big rise of Gen AI. But, you know, a first-party service with Microsoft is something special. So here is Satya talking at a couple different conferences and events about how Azure Databricks and its scale has helped the world's largest customers to organize all of their data with AI. And it connects. All of the data organized in Azure Databricks connects to all of the AI systems, Foundry, Copilot, etc. of Azure. And all of the AI stuff of Azure can be used in Databricks. So it goes back and forth really, really well. The other thing is Azure Databricks, since it's a first-party service, we have direct integrations with all of the hallmark capabilities of Azure and Microsoft, all of the core services. And that's how we've been able to deliver all of this customer value to customers globally across the whole world. Now, this is the overall architecture we have. We call it the Lakehouse, and Azure Databricks runs on this system where you can organize all of your data in your account in ADLS, spin up incredibly scalable amounts of compute using all the compute capabilities of Azure, and we handle all of the complicated networking and make sure it's all secure. So all of the data is owned and organized by you in your ADLS account, typically in formats like Delta or Iceberg. It's all organized by Unity Catalog, and once you do that, you can do massive data processing, you can build AI agents and optimize your business with those, and you can do all the data warehousing capabilities, etc. And doing this, we spin up over 23 million machines a day across all of these regions of Azure. So if you think about it, this requires three fundamental capabilities: very elastic storage, very elastic compute, and very elastic networking, including things like private link, etc. So we can do this on a global scale for the largest customers in the world. And the really key thing is Databricks engineering is side by side with Azure engineering around these areas of compute, storage, and network, and all the security primitives inside. So for example, if we're working with a customer and they hit a gap in what we can do collectively, I can text Manish, we put together a hot team on that and address the customer situation in days, weeks, etc. So it's very adaptive, and to do things at this scale, we need to work side by side. So our partnership with Microsoft is incredible. It's the most important partnership we have, and it allows the two engineering teams with this first-party product to build this incredible elastic scalability together and help you solve your business needs. So thank you for joining us. I'm honored to be part of the session, and enjoy the rest of the session. Thank you.
Okay, thanks. But impressive scale, right? So we take a systematic approach. So cloud-native applications need compute, storage, and networking. So now I'm getting into my favorite part of the talk. Talk to you about a little bit of networking innovations that we've been doing. Number one is Azure Managed Cilium. So with the cloud-native apps, you need higher performance networking. Now, of course, customers can bring their own Cilium or their own CNI and use it. But when they use the Azure native Cilium, along with what we call as ACNS, Advanced Container Networking Services, you get a ton of benefit from this. One, we now do a L3 to L7 policies, which you can do like in FQDN-based policies for your pods. We do better observability through pod-level metrics, open source project Latina, so we have a managed version of that as part of ACNS. And we also have pod-to-pod encryption enabled through WireGuard, the host-to-host encryption. And the best part of it is performance acceleration. Just your pod-to-pod data transfer rates would go up by 9% just by using Azure Cilium, because we eliminate double encapsulation at the host layer. Now, when you use the eBPF host router functionalities, which is in preview, you may get as much as 50% improvement on performance between pod to pod. Many of our AI workload customers who are running in AKS use Azure Managed Cilium. Along the lines of security, we are also announcing WAF for Application Gateway for containers. So AGC has been there as a layer 7 load balancer for container workloads for many number of years now, but we were missing the functionality of WAF. Now we kind of put all of this together so that you don't need an extra hop for this thing. So that is generally available as well. A quick announcement also is on Azure Bastion. How many of you use AKS private clusters here? That's a good number. So we see a lot of customers using AKS private clusters. But when you use AKS private, and when you want to connect to it from outside, you either have to open up an internet-facing endpoint, or you have to run your own jump box in a VNet to connect to it. We eliminate all that hassle. Azure Bastion, which you already use for your VMs to connect securely, will now extend itself to also connect to the private AKS cluster. So that's a nice little addition. Will be public preview as of today. Last, I do want to talk about storage, because as you have a need to run more stateful containers, you need a stateful storage service. Now, Azure Container Storage abstracts all of our storage offerings and offers to you in a very API-driven, programmatic way. Now, what's new with our V2 version of our Azure storage? Now, we have improved the performance using NVMe, and the best of it is it's available to use not just with AKS, but just also with your own Kubernetes and any open source Kubernetes as well. Last thing, when we talk about open source, I'm very happy to say Azure is a leading provider of, from a cloud hyperscaler standpoint, we are the leading hyperscaler to contribute to many of the CNCF projects. We believe in open source, innovating the world for all of us, and we'll continue to do that. Now, as we think about running AI workloads and performance, I want to invite Aung to stage to talk about it. Thank you.
Thank you, Narayan. AI is no longer experimental. It encompasses our day-to-day life. And I'm glad to share how Azure Core is transforming AI workloads on Azure. Enterprises and developers need infrastructure that scales for AI workloads across training, fine-tuning, and data processing. Azure delivers end-to-end optimization with unified compute, storage, networking, and orchestration layer together in one single platform. At the core is purpose-built GPU VMs, scaling virtually without any limits to accelerate innovation. Our networking stack uses both InfiniBand and ExpressRoute for ultra-high bandwidth and low latency. Storage platform is secure, integrated, and built for massively scalable from terabits per second at exabytes capacity scale. Along with that, we have Azure Boost and general purpose VM SKUs empowering AI workloads. We also have native integration with AI framework to speed up the development to reduce the complexity. Microsoft partners with NVIDIA and AMD to deliver the most comprehensive GPU portfolio. Azure was the first to offer AMD MI300X, and will soon add AMD MI455X. We also lead with NVIDIA Blackwell-based GB300 systems, setting new training and inferencing records. These partnerships keep Azure in compute innovation, giving customers early access to the fastest AI hardware. Next year, NVIDIA Vera Rubin launch will bring unmatched flexibility and global scale for AI. Imagine this. If you are doing a fine-tuning workloads for a medical imaging system, say these models are mid-range with billion parameters across hundreds of GPU nodes. We offer NC Scale, NC Series VM, which is ideal for mid-range to smaller range models with great price performance. Choosing the right GPU is the right first step. When you are scaling to hundreds and thousands of GPU nodes, you need a faster network, which is secure and scalable for AI training and fine-tuning workloads. Within GPU cluster, our sub-millisecond network latency accelerates gradient updates across GPU, ensuring efficient distributed training. You will need to keep GPU fully utilized. Idling GPU is not an option for us. In that case, training data set must be transferred from storage to local GPU memory at the highest possible bandwidth. Here's what we deliver. We offer a dedicated WAN for AI with more than 12.8 terabits per second bandwidth, powered by large-scale cooperated transport on SONiC, the first of its kind in cloud. You would ask, what if your training data is still on-prem? We have a solution for that as well. Let's talk about ExpressRoute. You need ExpressRoute for private and secure connectivity between your on-premise and Azure. ExpressRoute now delivers 400 gigabits per second bandwidth for data transfer directly from edge to cloud. This is 4 times of the scale at only 3 times the cost. Another added benefit is customer can use less number of circuits, avoiding additional CapEx on-prem routers. Now you have established the network connectivity from edge to Azure for data transfer. And the next question that people normally ask is how to store its data efficiently while delivering the performance that GPU needs. To store data sets for fine-tuning workloads, Azure Blob Storage is the storage of choice. It offers exabyte scale capacity, terabits per second throughput, along with smart tiering for cost optimization. This makes it ideal for ingesting petabytes to exabyte data quickly and securely. I want to mention that it is also the choice of OpenAI users for managing massive data sets, which speaks to its scale and performance. There's another scenario. After your data preparation, your data set size is low petabytes to terabytes, but you need high throughput to keep your GPU fully utilized. Azure Managed Cluster is a solution for that scenario. It delivers up to 500 megabytes per second per terabyte of capacity. And join us tomorrow for our breakout session, BRK171, tomorrow to hear about NVIDIA share their story on Azure Storage. I want to show you a demo highlighting the performance and scale of blob storage through a benchmark loading large-scale data sets and writing checkpoints.
In this demo, we've set up a cluster with around 100K cores to generate massive read and write loads on a single scaled Azure storage account. In the write phase, we're allocating 480 nodes. Each node mounts the storage account using blobfuse2, a virtual file system driver to access your existing data through the Linux file system. Streaming data directly from Azure Storage, the dataset we'll use to simulate distributed reads and writes is approximately 1.5 petabytes. First, we write all the data into our storage account using a script that runs with the IOR benchmark, a parallel I/O benchmark, across all 480 nodes with 24 processes per node. As the script executes, you can see all client nodes streaming data at maximum speed. We're hitting an incredible 22.3 terabits per second for writes. To put that in perspective, that's writing a 100 terabits checkpoint in just about 35 seconds. Next, we read back all the data we just wrote, again, streaming directly from the storage account. For this phase, we're using 695 nodes, different from the write nodes, to eliminate any caching effect. All nodes mount the container through Blob Fuse 2. The read performance is even more impressive, 51 terabits per second. To give you a real-world analogy, at 51 Tbps, you could stream 2 million 4K videos simultaneously. This isn't just a benchmark. It's showing how Azure is evolving rapidly to meet the demands of the largest AI workloads on the planet, delivering unmatched scale, speed, and reliability. Whether you're training trillions of parameter nodes or orchestrating real-time inferencing pipelines, Azure Storage is engineered to keep up and push the boundaries of what's possible.
This is a groundbreaking performance. For many of you, tuning a model from scratch is not necessary. Your preference might be to leverage existing AI services to run inferencing with pre-trained model. You can then overlay them with RAG for domain-specific knowledge. And Azure makes this simple because Azure Storage deeply integrates with AI services to bring enterprises' data into AI agents. For instance, Azure AI Foundry service connects with blob storage, both as a source for enterprise data, as well as a destination for AI-generated outputs. Today, we are announcing 4 new Azure AI services integration with blob storage as listed here across AI Foundry to AI Search. We also recognize that many of you use open source framework to build AI applications. Azure Storage deeply integrates with this ecosystem, as well with support of LangChain native loader and PyTorch connector for blob storage. Once your data is in place and your models are ready, the next challenge is delivering inference efficiently. This is where direct virtualization comes in. Direct virtualization enables a more efficient approach to nested virtualization on Azure VMs. You can deploy child VM as an inference workers on a single host with direct access to GPUs and NVMe disks. This delivers near-native performance for I/O, almost no overhead of nested virtualization. We also enforce strong isolation between tenant VMs, so you can run sensitive workloads side by side. By maximizing GPU utilization, you get more inferencing runs per dollar with less operational overhead than bare metal. We just covered how direct virtualization delivers efficiency for inferencing VMs. What if your infra strategy leans towards open source frameworks and Kubernetes? In this scenario, Kaito is a suitable choice. Kaito is an operator that automates AI model inferencing and tuning workloads inside your Kubernetes clusters. Performance acceleration is another area where Kaito shines with Azure Container Native Storage. It dramatically reduced cold start time by a factor of 6 compared to before using local NVMe to stage large model weights. Azure not only powers Microsoft AI frameworks, but we also partner with leading AI framework, provides to give customer the broadest choice for building and scaling AI solution. And today, I'm excited to highlight our recently announced collaboration with AnyScale, which brings Ray to our platform. Azure is entering an era where AI is our foundation of how we run our cloud. And as environments grow more complex, traditional tools and manual workloads can't keep up. Agentic cloud operation makes a new model for the AI era. And Azure Copilot ensures every action, whether initiated by a person or an agent, align with your policies and standards. We list a couple of newly announced capabilities, and these capabilities are in private preview today. Here is a quick recap of innovation that we covered today. In order for us to innovating from silicon to applications, we announced latest in Azure Compute, networking innovations, and industry-leading storage offerings. We wanted to ensure that Azure is a platform for business-critical, cloud-native, and next-gen AI. These are the sessions from Azure core team, and then we hope to see some of you in our upcoming sessions, and thank you so very much.